Hello and welcome to part 3 of this ClearML onboarding video series. If you missed parts 1 and 2, you can check out the links down below to catch up. In this video, we'll finally be taking the models that we trained in parts 1 and 2 and serve them within the ClearML ecosystem. So this is super exciting and I won't hold you any longer. Let's get right into it. ClearML supports two types of serving solutions. Batch serving, also called offline serving, and online serving behind a REST API, using a model serving engine. Batch serving can be done by creating an inference task and making sure to parameterize all the settings that you want to change later on, just like we did in a previous video with remote execution. You can then easily clone or schedule the serving task, edit the dataset ID that it should be run on, and let it be executed by one of your workers. Online serving, on the other hand, is done by employing a model serving engine called ClearML Serving. If you need to serve deep learning models, it will use the optimized NVIDIA Triton engine to do some of the heavy lifting to ensure maximum serving speed. If instead you're serving a CPU-based model, it will run a ClearML inference engine and utilize the Intel optimized OneAPI libraries. Later in the video, we'll see that we can take a model from our ClearML model repository that we saw in the previous video and expose it as a REST API using nothing but simple commands in the terminal. It supports seamless model updates, A/B testing, and canary rollouts. We'll set up a model monitoring stack using Grafana, and I'll show you how you can add your own custom metrics simply by using the CLI interface. ClearML Serving can be installed as a Docker Compose stack or inside Kubernetes, where it can easily scale horizontally to take whatever load you can throw at it. That's all for later in the video though. Let's start first with batch inference. So first of all, if you want to do batch processing or batch inference, you're going to want to just simply use a task, right? A ClearML task, just like any other. Remember, you can clone them however you want. So if you parameterize the code well, you can use the same inference task to run it on basically any type of data that you want. So this is just an example, and again, all of this code will be available from the description. So we just initialize the task, give it a project name and a task name just like we did before, and then this time we can use the task type set to inference. Now this doesn't actually change any of the workings of ClearML, but it does allow you to filter and sort better and more easily within the ClearML experiment manager, and also if you want to query it using the SDK, this might come in handy later on. So when you initialize the task here, then we can read the data into the matrix, we can get the model, and get this, we can get the model from a different task. So what would immediately be apparent, or what should immediately be apparent here, is that actually what we want to do is take this task ID and then turn it into a parameter, task ID right here, and connect that parameter to our task, right? Because we want to be able to override this parameter. Now, you can use .connect on like Python dictionaries or Python objects. If you want just a single scalar or a single parameter, you can just set parameter, just like that. Mind you, that this might change in the future. So I want to set the task ID as a name to task ID, like this. Now we want to set the task ID here, and what will happen is whenever we use the set parameter, whenever we run this task, we can actually override this parameter from the UI, just like we did before, and then starting from this line, it will be completely different based on what you gave it, and then we can get the model from a different task if required. Now we can read in the actual model by getting a local copy, just in the same way as we do with our dataset. And then from this task, right, from the task that created it, and then we can load the model and run our predictions. Then you have several options. You can put these predictions into a new dataset, into a new dataset version, or in this case, you could simply upload it as an artifact of this inference task. Now, if I run this, it should just run, get all of the data, get the task, get the original model from that task, load it, do all the predictions, and upload the artifact. So let's see and come back when that's done. All right, so the inference task is successful. If we now go back to our ClearML, under projects, we have our full overview here within our normal full overview, we have batch inference right here. We have our configuration. In this case, our task ID is going to be the task ID of the model that we get. So I should have named this better, but it is captured correctly. So if we now clone this, we can actually override this. And then obviously we have the console output here. And most importantly, we have the input model. This time it's an input model. Usually you get an output model. For example, here you'll get an output model of the actual best model. In this case, we're using it. So it's becomes an input model. And then we also have the predictions themselves, which is stored as a pickle file for the data frame. And we can see a preview right here. And we can get this result programmatically using the SDK from anywhere. So this is one of the awesome things about ClearML, again, is it's all connected to each other. Now, this is offline inference. As you can see, it also has a different icon for being an inference task rather than a training task. Now, this was offline serving. You want to do this if you have batches that you want to go through. Now, if you want online serving instead and create from your model an actual API, we're going to want to use ClearML serving instead. So that's what we're going to do right now. Now, if you want to do online serving, you'll need a model serving engine. Now, the reasons for this are multifold, but one, for example, is to reduce cost. If you're just going to create or put your model inside a Docker container and check it on a machine somewhere, it's not going to be very efficient. And so to reduce cost and to maximize machine utilization, you want to use a model serving engine such as ClearML serving. A second reason is scaling. It's very much a similar thing, is like it can automatically scale out of the box using, for example, horizontal scaling in Kubernetes. And then another reason is you have monitoring, model monitoring right out of the box. It is not something that is very easy to add in these kinds of rapid fire deployments as part of a normal Docker Compose. And then finally, it's also very, very handy to use these kinds of model serving engines in terms of being able to deploy models using a CLI or an SDK and automate a lot of that process as well. So that's actually several reasons why you want to use ClearML serving if you're going into an online serving scenario as compared to this batch inference. ClearML serving, however, adds a bunch of things on top of that as well. So it is based on NVIDIA's Triton inference engine and then adds a wrapper around that with convenience features and integration, deep integration with the rest of the ClearML ecosystem. So if I take a look here, this is our documentation, and this is the introduction of ClearML serving. There are several features here. So one, it's easy to deploy and configure. You can use a CLI tool and nothing more, just to take your model from ClearML and put it into this model serving engine. It supports all of the different machine learning models, deep learning models, sklearn, XGBoost, all of these frameworks are all supported. And obviously you can create a customizable REST API for your serving. It's very flexible, so it runs basically everywhere. I have currently deployed it on a Docker Compose stack to show you how it works. You can also run it on Kubernetes. It's very scalable, especially on Kubernetes. It can horizontally scale and really get a lot of load and efficiently scale on your machine as well. It's efficient, so it's better. It makes better use of your machines. And then automatic deployment is the big one for me. So personally, I hate it when I have to do like a whole different bunch of steps and set up something new every single time. In this case, ClearML serving is meant to be a deploy once, update forever kind of system, where you once and for all deploy your model and then you can seamlessly update it when time goes on. So it's kind of a blue-green deployment strategy where you can say, hey, this is a new model, just go from one to the other seamlessly without people ever missing a beat. You can also do this in an A/B testing scenario, which allows you to serve two models to the same endpoint in a different fraction of the amount of traffic coming in, going to one model versus the other to test out a new change. And you can also do canary deployments, which basically means lower or higher this fraction over time unless there is an issue, and then you can scale back to your previous model. So all of this stuff is built in. And then there is also the big one, model monitoring. That is usually the big one that is being talked about the most. That is model monitoring. It's based on Grafana and Prometheus, and it allows you to keep tabs on what your model is currently doing. All right, so let's take a look at how we set this up. So I have actually set up a Docker Compose stack that uses, or like that sets up ClearML serving as the service, right? But now once you've done that and Docker Compose is running or Kubernetes is running, you only need the command line from here. So I have here ClearML serving, and I'm going to set an ID, and this is actually the ID of the serving endpoint task. And you'll see this once you've set up the Docker Compose or the Kubernetes task, you'll see that a new project is coming up, and that's called DevOps. Now we have our scheduler running here still, so that's also being scheduled in DevOps. This is the one that we created earlier, but now we also have 3 more, and it's a serving control plane, a service for the statistics, and a service for the serving. And currently we see in our configuration that we have no endpoints here. Also, the serving control plane has no endpoints, has no metric logging, or has no model monitoring. That's what we're going to change. So we want this serving control plane's ID as it ends on 989. So that's what we're going to be using. And that's this one right here. Now, I am not going to add metrics just yet. I'm going to add a model. So this is the first thing that I want to do. I want to set up ClearML serving with this ID, which is the control plane that I just talked about, add a model with engine XGBoost, the one that we currently trained, an endpoint called fashionMnist, and then a preprocessing file. Now the preprocessing file, let me go there, is, where is it? There we go. Serving preprocess is a relatively simple file that defines the inputs and outputs of going in and out of your model, right? So in this case, I have no internal state whatsoever that I want to keep track of. I have some preprocess here. I can print whatever is coming in. I can get the pixels from the body, and then I can return an XGBoost matrix to be sent to my model, right? This can be completely custom. It's very, very easy to add some like random custom preprocessor post-processing code in this file. And then post-processing, I just get the Y around everything, because that's how XGBoost works, and then get a list of that. So this is a very simple file that does the preprocessing for my endpoint here, and then I have the model ID as well. So if I go back here in my ClearML web UI, I want to go to my full overview project, go into full overview. I have here my clone, for example, or my normal XGBoost simple example, and I can go to my models and get the best model. Which one should I use? I can, for example, use this one, get the ID, and that's the one that I want to deploy. Now, obviously, you want to do this much more carefully. You want to add tags and have release schedules and stuff like that. Currently, I'm not doing that just for the sake of speed. So I'm copying any old XGBoost model and hoping that will work. So I'm adding that here. And what ClearML serving will now do is basically add this endpoint to the already running serving stack, right? So again, it's deploy once, update forever. So it's saying I am updating the service, the serving service. And then now if we go back to our DevOps serving control plane right here, under configuration, we should now see that we have a new endpoint right here, fashionMnist on XGBoost with this model ID. Now, this will always give you visibility into what model is deployed at any time. If we go to our plots, we have to go to the plots of the serving instance and hope that it already synced, because the serving instance is going to sync with the serving control plane every X seconds or minutes or whatever. And so in this case, our serving instance has not yet synced, so our configuration object for the endpoints is still empty. If I update it here, there we go. Now it's updated, and if I go to my plots here, you'll see that I now have a table with some details on which model is deployed in to which endpoint, right? And we also have our serving endpoints layout. Obviously, currently, we only have one fashionMnist. I can always click on this and go through to the best model. I can then get the task ID that was originally used to create it, go back there, and then you could click through the whole journey of that model, because that's what ClearML end-to-end allows you to do, right? So now we have deployed our fashionMnist endpoint, our model, right? If I now go to my notebook that shows you how to infer on that endpoint, I can show you what this is doing. So first we have to define our API endpoint. This is localhost. Again, I'm running this on Docker Compose on the fashion MNIST serve endpoint. Then I get my data set. Again, just get it from ClearML data. I want a test set of that data set, and then for I in range of the length of that test set, I want to infer on only that image. So I'm basically sending one image at a time to this endpoint. All right, if I then take a look, if I run this, this will take a long time to run, right? But as you saw earlier, let me just show you first and break for a second, and then do response or print response. Body, there we go. You'll see that if we only do one of them, or like we send only one response object has no body, it's plotted JSON. There we go. Wait 4 seconds. There we go. So here we have our reply, which is y equals 3. Now we want to do this a bunch of times, just so we can set up our model monitoring as well. So I'm going to let this keep running. And then in the meantime, I want to set our monitoring up with just a single command line. So I want to do ClearML serving with the ID of my control plane, metrics add, and then on which endpoint do I want to add which metric, and then I can go nuts, right? So in this case, what I want to do is keep track of a scalar that is y. So I want y, the output of the model, to be tracked in real time and put into buckets of 0, 1, 2, 3, 4, 5, up till 9, which is the different classes that fashion MNIST can have. If I do this, ClearML will essentially say, okay, for every time now that a new request comes in, and this is being done right now, we're currently doing that, I want to also keep track of the output of the model, not just the latency, for example, that is usually in ClearML serving by default. And what this allows us to do is, for example, monitor for model drift, right? Or any other type of metric that you want, depending on how you set up your stack. So what our goal is now is to actually see these, and actually monitor these metrics, right? And so what this Docker Compose stack also does, you can actually see the output coming in here. What this Docker Compose stack also does for us is set up a local version of Grafana, or at least a version of Grafana that is accessible from the machine where you're running the Docker Compose stack. In this case, it's my local host. So I want to go to localhost 3000 and use the default admin password, and then it will prompt you to add a new password. Obviously, I'm going to skip this for now, never doing this in real life, however. And then I want to create a new dashboard. And now I have access to all of the metrics that ClearML generates automatically, and also the metrics that I want to add manually. So I did already add one. Let's create a new panel, go to Prometheus as the data source, and then on our metrics browser, we can see that we have all of these right here. So fashion MNIST count created, count total, latency bucket, blah, 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 blah. These all are the basic normal settings. Right, so I'm going to get some of these metrics sorted out, and now we can take a look at the result. All right, I actually wanted to skip this step because the video is already getting quite long, but I think if you're still here, you might want to know this. So this is actually going to set up what is called a moving histogram of latency. So here we're actually looking at the change of fashion MNIST latencies buckets and then comparing it to the total sum. So you get like a relative histogram over time. And then we obviously do that times 10 to get the percentage. Then if we go here and change from time series to a heat map, we can then also change from time series to time series buckets, because that's how ClearML keeps track of this. And then we can change the scheme to something that I like more. If I now apply this, what you'll see here is that these are the different buckets. For every column, you have a specific timestamp, which is a single minute, and then you have the distribution of the latency within that minute on this column right here. So this is, for example, 37%, this is 20%, and 30%, and 11% is only in the last 0.050 latency. So this is usually what is being used for latency analysis. And let me change this to another panel. This is how I actually did it. So change the source to Prometheus. And now in the metrics, in the query, I actually want a fashion MNIST, but instead of the latency bucket, I now want the, let me check, just so I'm sure. I want the Y bucket, because what we created before, and let me change that to there. There we go. Well, what we used before is we get track of the Y value, right? Of the output value of the model. So now if I change this to a heat map and then go to time series buckets, this is, by the way, all in the GitHub repository, right? Especially the one from ClearML itself. So don't worry. But if I apply this, you have the very, very same kind of analysis here, but this time it's the distribution of the incoming data. And so this is just two very simple examples of what you can set up in terms of monitoring, what you get out of the box in ClearML, and then what you can do if you really, really dig into it. So this is, yeah, I should probably set the titles, but that doesn't really matter that much. You can then additionally set up drift detection algorithms, for example, on here. And a big one is you can use Grafana's inbuilt alarm system of alerting system. I actually want to save the dashboard. You can set up all types of alerts to alert you when, for example, drift is off or there's like too many unknown outputs of the model or stuff like that. So this is kind of the monitoring that ClearML comes with. Now, with this setup, we have finally completed our stack for today. Now, thank you for soldiering through with me on this. This was a lot to digest, but I hope you found it interesting. We took our very simple model training script that trained an XGBoost model from the beginning, and we turned it into a triggered automatic retraining pipeline that can be triggered with newly incoming dataset versions that can then also publish a model that we can take into ClearML serving to serve as an API, all with Grafana as its model monitoring to boot. So this is quite a stack to set up. And again, thank you for your attention on this. There's even more features, believe it or not, that I didn't mention yet, or that I didn't have time to mention, especially for enterprise users. So for enterprise users, there's RBAC, so role-based access control. There is vaults, secret vaults as well. We have an unstructured feature store for unstructured data called hyper data sets that you also have access to from the enterprise tier. You have better Kubernetes integration, and you have Gragio and Streamlit apps as well, or integration. So if you have a Gragio or a Streamlit app, you can also serve those from within ClearML. It's an application that you can use if you're in the enterprise tier. So there's so much more that I didn't talk about yet, but let that not stop you from starting right now for free at app.clear.ml. You get a free server from us just to get started. You can always self-host your own server or upgrade to the Pro and Enterprise tiers. Now, if you want to actually scale your ML pipelines and data abstractions, and you want unprecedented performance and control, you can always schedule a demo at clear.ml/demo. There's also our Slack channel in which you can talk to us and our community, and you'll have all of your questions answered. Thank you so much for watching.